Welcome to solverfy.
So here we are going to use equation 37.8 to find the Lorentz factor. And we can say that the Lorentz factor gamma would be equaling 1 divided by the square root of 1 minus the velocity divided by the speed of light, quantity squared. This is going to be equal to 1 over the square root of 1 minus 0.99000 quantity squared, and this is equaling 7.0888. We can then say that the momentum is going to be equal to the Lorentz factor times the mass times the velocity. This is from simply equation 3741. And we can then say that the de Broglie wavelength of the protons would be lambda. This would be equal to the Planck's constant divided by the momentum. This would be equal to the Planck's constant divided by the Lorentz factor times the mass times the velocity, and we can solve. So this would be 6.63 times 10 to the negative 34 joules seconds, and then divided by the Lorentz factor, 7.0888, multiplied by the mass, 1.67 times 10 to the negative 27th kilograms, and then multiplied by the velocity of 0.99 times the speed of light, 3.00 times 10 to the 8th meters per second. And we find that the wavelength, the de Broglie wavelength, would be 1.89 times 10 to the negative 16th meters. So we can then say that the vertical distance between the second interference minimum and the center point would be considered y sub 2. This would be equal to 1 plus 1/2 multiplied by the wavelength times L over D. This is equaling 3 over 2 times the wavelength times L over D. And we can say that L here is the perpendicular distance between the slits and the screen. At this point, we can then create an equation. The angle between the center of the pattern and the second minimum would be tangent of theta. This would equal y sub 2 over L, and this is equaling 3 times lambda, the wavelength, divided by 2d. And we know that here the wavelength is much, much less than the distance d. So we can say that here tangent of theta is going to be approximately equal to theta. And so we can say that theta would then be approximately equal to 3 times lambda over 2d. And we can then say 3 times 1.89 times 10 to the negative 16th meters divided by 2 times 4.00 times 10 to the negative 9th meters, and the angle would then be 7.07 times 10 to the negative 8th radians, or we can say this is going to be equal to 4.0 times 10 to the negative 6th degrees. This would be our angle theta. That is the end of the solution. Thank you for watching.